Hi, this is Norm. Let's talk capacitor essentials for Johnstone sales and counter employees. Oftentimes, customers will come in with a capacitor or they will need to have a replacement capacitor. There are a few things that you and I need to know about capacitors in order to give them some assistance in finding the right replacement. So let's go ahead and take a look at some essentials. Here you see a technician holding a capacitor at his left hand, and he's at an outdoor condensing unit for an air conditioning system or a heat pump. And capacitors are generally used with HVAC equipment, especially with motors. So some compressors in the condensing units use capacitors to help them start or to run more efficiently, as well as outdoor condensing fan motors and indoor motors. So capacitors are used with motors. Capacitors can wear out. Capacitors are electrical components that are subjected to voltage fluctuations, and during normal use, they constantly are charging and discharging as they assist the operation of a motor. In addition, they are susceptible to lightning strikes as well as possible line voltage surges riding on top of the incoming alternating current. These surges can only last for a few microseconds, but they can weaken a capacitor, and the capacitor may be subjected to hundreds of these microsecond voltage surges over the years. In addition, capacitors located in the outdoor condensing unit are subjected to wide temperature changes. In the winter, they may reach temperatures well below zero, and in the summer may go over 120 degrees in the cabinet. This causes them to expand and contract, which also decreases their electrical values as well as contributes to their deterioration. Moisture is also a factor in the life of a capacitor. So yes, they do weaken over time and they do wear out. Capacitors normally last for quite a few years unless subjected to any of the factors already mentioned. In the past, capacitors were much more hardy. Capacitors of 40 or so years ago were larger and contained a cooling agent called a PCB. PCB fluid or paste worked well at preserving capacitors, but was determined later to cause cancer, so they were outlawed. Modern capacitors do not use PCBs and have been manufactured so as to be physically smaller. And today's capacitors do not have the longevity as those of the past. Like a light bulb, we cannot predict when a light bulb will fail, or some light bulbs may last much, much longer, while others fail early. I consider capacitors to be dissimilar to light bulbs. It becomes a judgment call as to if and when you want to require or to we replace an older capacitor. A capacitor is actually pretty simple. A capacitor consists of two metal foils, each with a wire attached. The two foils never come in contact with one another. Each foil is physically separated by a sheet of what amounts to waxed paper. The two foils do not conduct electricity between them. When in a circuit, electricity charges and then discharges the capacitor. The assembly of the two foils and the wax paper are rolled up and placed in a cylindrical container. Run capacitors use metal containers, while start capacitors are in bakelite or plastic. The function of a capacitor is to assist a motor in starting and running. The motor may be a compressor motor, an outdoor condensing unit motor, a fan motor, and the indoor blower motor, but not all motors need a capacitor. There are several motor types that do not use capacitors at all. The construction of a capacitor was discussed earlier, two metal foils separated by an insulator, and each foil has a wire attached. The wires are attached to spade terminals on the top of the capacitor. There are capacitors with three connectors. Capacitors with three connections are dual capacitors. They have two capacitors in a single enclosure. Capacitors are rated for the highest voltage they should be subjected to. For example, a capacitor rated at 480 volts can be used at any voltage less than that. You can always use a replacement capacitor that is rated for a higher voltage than the one being replaced. Capacitors are also rated in their capacity. Capacitors are marked in microfarads. A microfarad is 1/1,000,000th of a farad. A farad is a very large unit of measure by itself, far too high for use in HVAC. The capacitance is marked on the capacitor and is marked with MFD or MFD in capital letters or small letters. Run capacitors are metal enclosures and are made to remain keep the motor in the circuit when the motor is operating. Run capacitors now have a low microfarad rating, such as 5 microfarads or 7.5 microfarads, perhaps 10 microfarads or slightly more, as listed on the capacitor. Start capacitors in the plastic or bakelite containers have much larger microfarad ratings, like 15 to over 300 microfarads. Here we are looking at a start capacitor on the right. We opened a start capacitor so you can get a view of the two foils and the insulator wound up or coiled up and placed inside its enclosure. On the left is a relay used to remove the start capacitor from the motor circuit after it helps get the motor started. Start capacitors are in the circuit just long enough to assist the motor. Run capacitors remain in the motor circuit all the time that the motor is operating and are enclosed in metal containers. Run capacitors are also physically smaller than start capacitors. Internally, their construction is identical. Start capacitors have more foil area, which increases their microfarad rating and provides more starting power to get the motor started and are then removed from the motor circuit by a relay. Run capacitors remain in the circuit and do not have a relay. Run capacitors also help the motor operate more efficiently. The start capacitor on the left has a microfarad rating of between 540 microfarads and 648 microfarads as marked. Note the microfarad rating is a range and the actual microfarad rating will be somewhere in between these two values. Start capacitors can be replaced with another of a similar range and need not be replaced with another of exactly the same range. Also note that the microfarad value may be labeled as UF or MFD, as both designations are used for the microfarads. In addition, our start capacitor has a minimum voltage rating of 330 and may be used at any voltage, but as long as it does not exceed that voltage. On the right, we have a run capacitor with a microfarad rating of 5 microfarads. Run capacitors do not have a range of microfarads, but have a fixed value. A good run capacitor was within a few percent of the microfarad value stamped on it. A replacement run capacitor should be selected with a replacement having an identical microfarad rating. In addition, this run capacitor has a maximum voltage rating on it of 370 volts, and so it must be replaced with another having the same voltage rating or a higher one. Never select a capacitor with a listed voltage rating that is less voltage than the original. Remember, the voltage rating is simply the maximum voltage the capacitor can handle. Always use a capacitor of equal voltage or higher. Do not select a replacement with a lower voltage rating than the original. Again, select a run capacitor replacement with the same microfarad rating as the original. Start capacitors can be replaced with another with the same microfarad range, or we can substitute another start capacitor with a similar range if an exact replacement is not available. Start capacitors are very forgiving, while run capacitors need to be replaced with one of the same. Capacitors are similar to light bulbs. Capacitors, like light bulbs, wear out or fail after long use. Service technicians should stock the common sizes of capacitors in their truck stock at all times. Capacitors are the most common electrical components to fail. The enemy of the capacitor is heat and moisture. Capacitors located in outdoor condensing units experience wide temperature variations between the summer and winter and may be subject to moisture as well. Capacitors are also subject to lightning strikes and power surges. Some HVAC systems have several capacitors to serve the various motors, such as the compressor motor, outdoor fan motor, or the indoor fan motor. Replacing a capacitor is very simple and straightforward, but be careful so as the capacitor may contain an electrical charge from the last operating cycle. With the system power turned off, then capacitor's charge may be bled off by shorting the capacitor terminals with a resistor, a screwdriver, or a voltmeter. Using a voltmeter on the DC scale to short the capacitor out and eliminate the charge is. A shorted capacitor is one where the internal foils are in direct contact with each other. A shorted capacitor is worthless and may prevent the motor from starting or even running at all. And don't mistake a bad motor for a bad capacitor. The motor may be fine, but is not starting or operating because the capacitor is the real problem. The microfarad rating of a capacitor may change over time, and this can prevent a motor from starting and running properly. The microfarad rating can change due to the expansion and contraction because of wide temperature variations over many seasons of operation. A leaking capacitor is obvious. The cooling liquid or the paste inside the capacitor may be leaking out of the capacitor. This clearly indicates the capacitor needs to be replaced. Capacitors may bulge due to heating and expansion. Placing a capacitor on a level surface is one simple way to see if the capacitor is bulging. A capacitor that rocks when placed on a flat surface is a capacitor that is bulging and has either failed or will soon fail. Look for leakage, discoloration, rust, indications of age. The capacitor on the left may still be a good capacitor, but is not trustworthy and should be replaced. These capacitors have 3 terminals. They are dual capacitors with 2 capacitors in the same enclosure. One capacitor may be for the compressor motor and the other for the outdoor fan motor. Look at the capacitor on the right. The terminal with 4 spade connections is always the common terminal with the 2 capacitors in the enclosure. The terminal with 3 spade terminals goes to the compressor motor, and the terminal with 1 or 2 spades is for the outdoor fan motor. Refer to the electrical diagram to make sure you are connecting the correct wires to the correct location. Internally, there are 2 breakaway connections that disconnect the capacitor foils from the terminals on top. If the capacitor overheats and bulges, the physical interrupters disconnect the capacitor foils from the connections. Using an ohm meter, you will not have a complete circuit or will not have continuity. Dual capacitors are very common. Make sure these dual run capacitors are replaced with exact microfarad values. The voltage rating of a replacement capacitor may be equal to or higher, but never use a replacement capacitor with a lower voltage rating. In my opinion, I would replace the capacitor on the far left and the one on the far right with new capacitors. The rust and corrosion on these capacitors indicates they may, like a light bulb, fail sometime in the near future. The capacitor in this photo may still be good, but I would not trust it. It is rusted and corroded, and the accumulation of cobweb material and dust could allow an electrical arc to take place. In addition, it looks like the top may be bulging as well. A bad capacitor can cause a motor failure and a more expensive service call sometime in the near future. Start and run capacitors are part of the starting components of a compressor. In this photo, we see a system that has not been cleaned and serviced in some time. The capacitor and motor starting components look worn, dirty, and corroded. I would recommend the customer authorize me to replace both the capacitor and the contactor. In addition, we should inspect the condition of the insulation on the wires and the quality of the electrical terminal connections. 3 of these capacitors are in questionable condition. I would be recommending removing them from service and replacing them before they fail. Many of our multimeters now have a capacitor microfarad testing feature on them. I highly suggest owning a meter with that feature. There are a number of ways to actually test a capacitor to determine if it is bad, as well as measure its microfarads as compared to the microfarad rating listed on the capacitor itself. I will create another video on how to test a capacitor and measure its actual microfarad rating. But run capacitors should be within 10% of the rated value. Many capacitors will have a different allowable percentage value printed on the capacitor. In reality, run capacitors within 10% of their listed value are acceptable for use unless they fail our visual inspection or look pretty bad. Start capacitors often have a resistor connected across the contacts. The resistor allows any residual electrical charge to bleed off when the power is disconnected. This makes the capacitor safe to handle, and you do not have to short the disconnected capacitor yourself before touching it yourself. But the real reason for the resistor is to bleed off the charge so a spark from the capacitor does not damage the relay contacts. Remember, start capacitors are wired to a relay that takes the capacitor out of the motor circuit after the motor starts. The resistor is there to help protect the contacts in the relay. Capacitors may be wired in parallel to add their values together. For example, if you need 20 microfarads and you do not have one, you can wire two 10 microfarad capacitors in parallel to get 20 microfarads. If you needed 15 microfarads, you could wire a 10 and a 5 microfarad capacitor in parallel and obtain 15 microfarads. However, never go lower on their voltage ratings. Stocking many capacitors on a service truck may become difficult. It'll take up more shelf space and add weight. An alternative is to stock a capacitor that has multiple capacitors in the same enclosure. AMRAD turbo capacitors do just that. A single enclosure containing as many as 4 run capacitors in the same enclosure solves the problem. In addition to the 4 individual capacitor values, you could parallel 2 or more using the supplied jumper wires to make other values. An instruction sheet is provided, making the microfarad selection simple. Well, there you have it in a nutshell. Capacitors are simple devices, not at all difficult. In a future video, I'll show you how to easily test a capacitor using a multimeter or a meter with the capacitor testing feature installed. Thank you for listening. This is Norm with Johnstone Supply.